Our first speaker is Dr. Ian Anderson. Dr. Anderson is the director of the University Partnerships and Graduate Education Programs at ORNL. He is also known as Dr. No on numerous television appearances. Before taking up this position, Dr. Anderson was Associate Laboratory Director for Neutron Sciences, overseeing the operation and scientific activity of the two most powerful neutron research facilities in the United States, that being the Spallation Neutron Source and the High Flux Isotope Reactor. Dr. Anderson joined the laboratory in March of 2002 to become the director of the Experimental Facilities Division at the Spallation Neutron Source, leading the construction of the target facility and neutron scattering instruments and the development of the user program. Additionally, Dr. Anderson is the chief book series editor of the Neutron Scattering Applications and Techniques book series. Dr. Anderson obtained a doctorate and a Master's of Science in Physics from Birmingham University and bachelor's and master's degrees in natural science from Cambridge University in England. Dr. Anderson spends a good deal of time mentoring and providing opportunities to a wide range of diverse young scientists. With that, please help me welcome Dr. Anderson.
Okay, so as you can tell, I wasn't born and bred in the South, right? You can tell? Okay. So we'll come back to that in a minute because it's an important part about what I want to teach you. So my interest in science started many, many years ago in the evil dark ages, right? When I was a student like you are, I liked to find out how things work, right? And so I would often do experiments. Now, I was going to tell you some of the experiments that I tried to do at home, but then I realized the parents in the audience were not going to like me giving you some ideas of what they could do and end up something like this, right? And so as I went through school, I had some really good teachers who helped me sort of continue with this idea of finding out how things work and testing things. In fact, my physics teacher, when I was at high school, was always complaining at me because the first thing I would do when I got a sensitive piece of equipment, or an instrument or something, was turn it upside down to see how it worked, right? And he got really annoyed, for want of another word, until one day, I used to play rugby when I was at school, and he came to watch one of the matches, and I was unceremoniously turned upside down right in front of him, right? He never let me forget that. Right, turning. So, but as I said, at school I had some really good teachers. They helped me. They persuaded me. They were the ones that told me, go to university, go to Cambridge, go and do a science degree. And they helped me do the extra courses I needed to go there. So, you know, your first point of contact is a good teacher. So I went and I did something called natural sciences, as you heard, at Cambridge. But then came my first major decision, right? Natural science, I did physics, I did chemistry, I did crystallography, I did math. I hated the maths, by the way. Anybody hate maths? I'm with you. But come towards the end, I had to choose, right? First big choice, was I going to do physics or biochemistry, right? Well, the biochemistry meant I'd have to stay in labs with all those horrible chemicals that smelled all the time and were driving me nuts with headaches and things. Whereas if I did physics, I could go and play with the radio telescopes. So which would you do? Radio telescopes, yeah, right on. So that's what I did. I went to play with the radio telescopes and forgot the biochemistry. Actually, I still like biochemistry. So I did that. Towards the end of those studies, I became interested in nuclear power. It was the thing of the day, right? So I decided to go and do a master's degree in the next step and study nuclear reactor physics and technology, right? Sounds good. It was fun, but that's when I actually met people who started introducing me to research, right? And that's what persuaded me to go and do a PhD. Now, why was I passionate about research? So if you've got a question, and I'm asking the students in the room, if you've got a question, you want to answer a question, how do you find out the answer?
Ask somebody.
Ask somebody, that's one thing. Typically, do you ask somebody, well, what's another answer? Go on the internet, exactly. So you got into this idea of going on the internet and finding out the answer. What if nobody knows the answer? What if you've just asked a question that nobody in the world knows the answer to? Try and come up with an answer, and that's what research is all about. Somebody's going to ask you a question or stimulate a question in your mind. Nobody knows the answer. You can't go to Wikipedia. You can't go on the internet because nobody knows. So imagine you can set up some experiments. You can do, not like that, right? You can do some tests, and you can try and answer the question yourself. And if you do answer the question, guess what? You're the first person in the world to know that. You're the first person that knows the answer to that question. Nobody else has done it before, right? And then you can go and tell people. You can go and publish and say, hey, look what I found. So that's really cool. So that was my passion for research. And it started there with asking questions that nobody else could answer. So from then, so I did the PhD. This took me, as you heard, to Grenoble, France. Remember this theme? I was in England. I went to France. And I got to use these big instruments that I could fire neutron beams at things and find out how they worked. Now, this was much more fun than taking them and turning them upside down, right? Get a neutron beam and fire it at something and see what happens. That can sometimes happen too, but never mind. Right, okay. So this was fun. So I was really enjoying this. And after that, after I'd sort of got to learn how to use these instruments, I got more interested, and this is quite interesting, I got more interested in how to build those machines than how to use them, right? So once I'd sort of worked out how they worked, I wanted to go and build the next one. So I ended up in the United States. Now remember this theme, England, this France, and now I'm in the United States. I went to work at what was then the National Bureau of Standards, which is now National Institute of Standards and Technology, to help them build their next new facility using these neutron beams that I'd been using all this time. So that's where I met the guy who was going to be my boss and has been a mentor to me all my life. He taught me a lot. He taught me to be confident in my ideas, and if I had an idea, to follow it through. Not necessarily listen to people who say, that's never going to work, forget it. Follow through the idea. Have the ambition to go and try something and find the answer. He taught me that, not to be worried about it might not work. Because you know what? If it doesn't work, you still found out something. You found out it doesn't work. Okay, that's a good answer. Nobody else knew it didn't work. So he was my mentor, and he learned, he was very good. He would ask me a question. He would not tell me how to do something. He would say, how do we do this? Right? So I wouldn't know, and I'd start, well, I don't know how to do that. How would I do it, right? That's what started me thinking about a new project. And so one of the questions I was asked when I was asked to prepare this is, tell us a couple of things that you're really proud of. Well, I have one here, right? This is one of the things I worked on. He asked me a question. So I've told you I do neutrons, right? Well, neutrons are neutral. How do you get neutrons from here where you produce them to over there 100 yards away where you actually want to use them? They're very difficult to steer, right? And so he asked me, how do you do this efficiently? This was the answer, right? You can come and play with it. Don't break it. It's the only one I have, right? This is what we call a neutron guide. It's made of mirrors. Now, you've got a mirror in your bathroom, right? Anybody know how a mirror works? You're answering lots of questions. Go on.
It would be able to reflect beams of light from any surface and create like an exact copy right there.
Right. So a mirror in your bathroom is a piece of glass with a layer of metal behind it, right? This is a piece of glass. These mirrors are a piece of glass, but not one layer of metal, but 2,000 layers on them. And each layer is only a few atomic distances thick, and each one is different. That's quite cool, right? And so we worked on developing these, and guess what? These are now used everywhere in the world. Any facility that has neutron beams has mirror systems like this that take those beams out a long way. right? Now, what that's doing is now it's not enabling just me to do my research, but it's enabling thousands of other researchers to do their research too. So you go that step of doing your own research to enabling others to do research. So I'm very proud of that. But the next step was even bigger. I came back to the States, right? So remember, I've gone now to, where have I been? I've forgotten already. UK, to France, to America, to Switzerland, and then back to America. This was my next big thing. I came to build this thing, right? Now the spallation neutron source, some of you may have had a chance to see this. It was, I came to do it in 2002. I didn't do it by myself, by the way. Right? The whole group of us, about 700 of us, building that. It took 7 years to build, right? $1.4 billion, 7 years. But again, followed this theme. This is enabling others to do research. This facility has thousands of users that come to use it to do their research. So you've gone from doing my research to enabling a few to do research to enabling thousands of people in the world to do their research using this. And I've got 2 minutes left. Okay, so let me skip on a little bit. You can imagine that after 7 years of building it, we were very proud the day we first got it going. In fact, one of the headlines, this was from the Knoxville News Sentinel, but there was one, I think, in the New York Times that said something like, Oak Ridge turns on monster machine. Yeah, well, that was SMS, right? So that was quite cool to read, right? You've turned on a monster machine. Okay, just for the last couple of minutes, I've been giving you a hint all the time. So I've done a lot of things that I'm proud of, but it's been a journey in many senses, right? It's been a journey across the world. I started in England. I went to France, and I'm going to have to try and remember this. I went to England, went to France, came to America, went to Switzerland, 5 years, I think, then went to Spain, actually, I missed that out, went to Spain for 1 year, and then back to France for 10 years, and then back to America. So I've traveled the world in what I do. That's also cool, listening to different ideas. And in the meantime, I've also been to other places. I've been to China, I've been to Japan, I've been to Korea, South Korea. I don't think I'd be back from the north. I've been to lots of places. So not only can I do the things that interest me, but I can travel and talk to other people who do the things that also interest me. So here's my parting message for you, right? And these are things that I learned from my supervisor. Think big, right? Think out of the box. Don't worry if your thoughts don't align up with somebody else's, right? That's good, right? You're going to ask a different question. When you've had these ideas or questions you want to ask, don't be afraid to follow those ideas, right? It will lead you somewhere. You don't know where. You might get a negative answer. That's still an answer, right? But don't be afraid to do that.
It's still an answer.
Exactly, it's still an answer. Never stop asking those questions, right? Don't think you've learned everything. Never stop answering those questions. There's always something new you can learn. And broaden your horizons like I did. Think outside Oak Ridge, think outside Tennessee. There's some really interesting people and some really interesting ideas elsewhere. And enjoy yourselves doing it. Thanks.